Hello students, today's video lecture is on the 6 types of synovial joints. First, let's remember what a synovial joint is. All your freely moving joints are classified as synovial joints because they have a fluid-filled space between the two moving bones. Now the knee is pictured here, but synovial joints include all your other moving joints like your elbow, your shoulder, your hip, your ankle, your wrist, your fingers, your jaw, your neck. All of those are classified as synovial joints. In our last lesson, we learned about the structure of a synovial joint, how the bones are covered in articular cartilage, and the joint is held together by a joint capsule, which is made of an outer fibrous layer and an inner synovial membrane. And that synovial membrane makes the fluid that fills the space called the synovial cavity. So all the joints that we're going to be discussing today have that same basic structure. What we're going to concentrate on today is how those different joints are able to move. And there are 6 different kinds of synovial joints. The first type of synovial joint that we are going to learn about is called a gliding joint. I feel like the name is fairly self-explanatory. It indicates that the movement between the two bones is a gliding motion. If we look at these sort of mechanical representations here and also here, we see that if these are representing the two different bones, their flat surfaces will glide across one another. This one over here, you see like 2 flat discs that will be able to move across one another, and they have an up and down arrow, but really this disc could move in this direction or this direction. And sometimes these even allow a rotation or a twisting. So the example that's been given here is the vertebrae, and you may remember this upper projection on the vertebra is called the superior articular process, and this lower projection is called the inferior articular process. And the reason I'm bringing this up is because between the two is a gliding joint where the superior articular process of one bone meets the inferior of another. And so we have this gliding or sliding effect that takes place between those articular processes. This is a short animation that shows you how the gliding might occur, and you have to really look closely. It's not a tremendous amount of movement. So you can see how the upper block slides just like the upper bone is sort of sliding around. So that's called a gliding joint. Some other examples of gliding joints besides the one between the vertebrae is the one between the scapula and the clavicle. So there's just a little sliding motion that takes place right here. And then also on the other side of the clavicle where it makes a joint with the sternum. This is a gliding joint as well. A couple more examples are the joint between each one of these individual carpal bones is considered a gliding joint. And if you look, I've actually deleted some ligaments, but there are so many ligaments that hold this area together that you kind of understand how really that's the only motion that's going to be allowed. And I've deleted some ligaments, keep in mind. Between the carpals and the metacarpals are just a gliding joint. So not much motion taking place. Another example that's close by is between the sacrum and the ilium. These two bones will have just a short sliding motion. And another example would be where the patella meets the femur. As we bend and straighten our knee, our patella, our kneecap, will slide up and down. The next type of joint that we're going to encounter on our worksheet is a hinge joint. As the name implies, it works like a hinge. So there's a little mechanical representation right here, and then a little bit more obvious one here. The joint that is being illustrated is between the humerus of the upper arm and the ulna of the forearm. And the ulna has quite an interesting sort of wrench shape that mimics this lower piece of this mechanical representation pretty well. And so we could see this lower piece could move down. That would be like when we straighten our arm, or it could move up like when we bend our arm. And it works just like a hinge on a door. So that's considered a hinge joint. Besides the elbow, another fantastic example of a hinge joint is the knee. So the upper bone here is the femur, and the lower one is the tibia. You can see how it would work just like a door hinge, opening and then closing again. Here's another representation of a hinge joint. Keep in mind, it doesn't actually look like a hinge. It's called a hinge joint because it functions or works like a hinge. Okay, the next joint that we're going to encounter in our notes is known as a pivot joint. And when you hear the word pivot, I want you to think of the word rotate or spin. So what we have here is one bone will be spinning in relation to another bone. The example that's pictured here, this bone right here is the radius of the forearm, and right next door to it is the ulna. Keep in mind we saw the ulna in the hinge joint on the previous page. That was where it was making a joint with the humerus. This is a different joint where the ulna is making a joint with the radius. So we're looking at this joint right here. And this mechanical representation kind of shows you how the radius will spin in place with regard to the ulna. So this represents the radius and this represents the ulna. Okay, so in our arm, it's up here. So those are considered pivot joints. Think rotate or spin. So here is a quick mechanical representation of a pivot joint. You see that sort of stick structure in the middle is turning or twisting, but the circle part is staying the same. And in this animation, if you watch the top end of the radius, you can see it spinning in place, while the bottom end of the radius is clearly moving all the way over the top of the ulna. So both of those are classified as pivot joints. The only other pivot joint in the body is pictured, and this is between C1, the atlas, and C2, the axis. And that's what allows us to turn our head, as in shaking our head like the no motion. So the joints between the radius and ulna, the top joint and the bottom joint, and this joint here are the only examples of pivot joints. Okay, one of the most recognizable types of joints is pictured here. This is known as a ball and socket joint. I don't really think it could be named more obviously. It is literally a ball shape fitting into a socket shape. And you can see how much motion is allowed at a ball and socket. It is the most movable type of joint. So the one that's pictured here is between the femur, that has the ball on it, and the socket is the coxal bone, otherwise known as the hip. So we get the most amount of motion out of ball and socket joints. I'm going to go ahead and circle this joint here. I feel like it's pretty obvious, but just so we're clear, that's the joint I'm talking about, and it's clearly represented here. And you can see in the animation, this is the upper bone that's moving, but look at how many different directions it can move, and it also can rotate, and it can do this like 360 motion. So there's almost no motion that you can't do at a ball and socket. Okay, let's take a look at the hip and how we can move forward and backwards. Twisting motion, let me change the view a little bit so you can see, twisting motion, and then to the outside and to the inside with that same joint. Same is true of the shoulder, forwards and backwards. We can also do a twisting, and then towards the middle, away from the middle. Okay, the next type of joint is called a condyloid joint, or sometimes known as an ellipsoid joint. Fancy names. This, if you look at it, it looks kind of like a reduced ball and socket, and it is. It can move forward and backwards, side to side. The only thing it cannot do is the twisting motion. Okay, so notice this part would be sort of the reduced ball and the reduced socket, and then we have the same kind of representation here. It's just not as well connected as the ball and socket is. And so the joint that we're looking at is between the radius and this group of small bones here called the carpals. And you can kind of see that this would be the reduced socket, and then this shape would fit into it as the reduced ball. And so we'll be able to move Our wrist joint, we'll be able to move our hand forwards and backwards and then side to side as well. So that's called a condyloid joint. So here's a representation of a condyloid joint, and you can see how it's a reduced ball and socket, but notice the motions forwards, side to side, and then we can make a circle shape, but no twisting or spinning. Here's another quick animation. You can see no flipping of the hand, and then same over here, side to side and forward, backward, but no twisting. Okay, our final joint type is a very specific location. There's only one example, and it's the one that's pictured right here between this carpal and this metacarpal. And actually, that's the first metacarpal there. So let's go ahead and label this picture is in zoom right here. So this is a carpal bone, and this is the first metacarpal, or we could call it metacarpal 1. Now, if we look at the way the two bones fit together, this metacarpal has sort of a concave surface, and so does this carpal. And they fit together in sort of a strange way. This illustrates it a little better, where this bone will be able to move in this direction and this direction, and then this one from underneath in these two directions. So this is called a saddle joint because of the way the rider would fit onto the saddle like on a horse. So this is a saddle joint, and this is the only example in the body. Okay, here's a quick animation of a saddle. Notice the arrows. So side to side and then forwards and backwards. Even you can make sort of a circular shape, but no twisting here. Okay, there you have it. We have the ball and socket, the condyloid, the gliding, the saddle, the hinge, and the pivot. And all of these are types of synovial or freely moving joints.